Okay, so the first one says identify the number of zeros for the polynomial shown. So if I look at this, it's going to be my degree. And the things that I look for are my exponents here. This one, x minus 3, has 2. This one has 1. And this one has an exponent of 3. So you guys should know from factored form that we have one factor. It's going to be positive 3. This one's going to have a multiplicity of 2. This next factor would be negative 2 with a multiplicity of 1, and my third factor would be 1 with a multiplicity of 3. That doesn't really answer your question. We're just looking for the number of zeros, which is just going to be, well, the 3 counts twice, so that's 2, plus your negative 2 only counts for 1, and you have your 3 here, because the 1, and so this is going to be a total of 6. Okay. Number 2, what degree polynomial has 2 imaginary solutions and 3 real solutions? Well, you just need to remember that your real solutions plus your imaginary solutions equals your degree. Okay. So for number 2, my real solutions, I have 3. My imaginary solutions, I have 2. So my degree must be 5. Okay. Number 3, it's the polynomial below has at least one imaginary solution. What could the minimum degree of the polynomial be? First thing you do when you're asked a question like this is you look at how many times it crosses. This one bounces off of the x-axis, which means this 0 counts twice. So there are 2 real zeros right here. Okay, at this point right here, because it bounces. Now this says at least one imaginary solution, but I know that imaginaries come in pairs, so actually it's going to be at least 2. It has to be at least 2. So here we have 2 real zeros and we have 2 imaginary solutions, and so 2 plus 2 is going to be equal to 4. So 4 is the smallest degree. It could be more than that. It could have more imaginary zeros, but for what we know that the answer is at least 4. Okay. Number 4, it says for the 7th degree polynomial, find the number of real and imaginary solutions. So if you look at number 4, well, I said the first thing you look at with these is how many times. So we have 2 zeros here. This first 0 goes through, so it counts once. This one bounces, so this is going to be twice. So right here, this tells me that I'm going to have a total of 3 real solutions. Okay, but we're looking for both real and we need our imaginary. Now, this is a 7th degree polynomial, so that means that if 3 of my solutions are real, then 4 have to be imaginary, because 7 minus 3 is equal to 4, because I know that all of my solutions must be a total of 7. Okay. Number 5, you actually need to go to Desmos. I thought I had this open, but apparently I don't. So give me a minute. There we go. Okay. So my third problem is we have x to the 5th. So x to the 5th minus 3x cubed, 3x to the 3rd, oh good lord. Okay, this is taking too long, plus 3x. So there's my graph right there. So it's asking for real and imaginary solutions. And if I look at this one here, what you see is this only crosses once, and it crosses at 0, 0. So this one right here, this solution right here, tells me that I only have one real solution because it only crosses once. So I'm going to go back to here. Okay. And down here, and so for this, I have one real because it crosses x-axis once, one time through. I know that my total degree should be 5, so if I have 5 total zeros and I subtract 1, it's actually going to have 4 imaginary. So that's just the first part.